Hello, friends. We are back very quickly with episode 115 of our weekly highlights. My name is Eric Nance, and yes, it feels like deja vu, but joined once again by my great co-host, Mike Thomas. Mike, how are you doing this morning?
Doing well. We're gearing down for a nor'easter here, but so far pretty quiet. We'll see how the next 24 hours goes here out in New England.
That seems to be a common theme these days. We're not done with winter just yet, are we? Huh.
I guess not. I guess not. 1 week till spring, I think.
Yeah, can't come soon enough around here. We're in the Arctic throes here in the Midwest as well. But, the warming trends on the horizon. And boy, speaking of warming stuff, we got some really hot items to talk about in this week's episode. So we're going to get right to it. And before we do, we definitely need to thank our curator this week, Sam Parmer. Wonderful curation as always from Sam. And he had, of course, tremendous help from our weekly team members and contributors like all of you around the world. So, Mike, do you hear that sound? You might say it's the winds of change are coming. We are on the cusp of probably one of the biggest developments we will see in the R ecosystem this year. Now, I don't throw that out lightly, but what are we talking about here? We are happy to share that software engineer on the Shiny team at Posit, George Stagg, has announced version 0.1 of webR. This is the WebAssembly compiled version of R that can now run in your web browser. Yes, this is a massive development. Is this a surprise? Well, not really, because we know this has been in the works for over a year. But we got hints of this more, you might say, fully when last year at PositConf, it was announced that Shiny for Python was now an alpha. But alongside that was a little project called Shiny Live, which meant that people like you and me could run a Shiny for Python app completely in a web browser without the need of a Shiny server. That technology behind Shiny Live and Shiny for Python for that you might call client side hosting is the same type of technology that's behind webR, and that's WebAssembly. WebAssembly, for those that aren't aware, is a way for you to compile basically binary versions of some kind of software or package routine so that it is run, as I said, completely in the web browser. And there is a lot of machinery behind this. We definitely don't have time to get into all the machinery today, but let's talk about what this gives us. This gives us a lot of possibilities, some of which we'll touch on in our next highlight shortly. But think of you having simply an R console in your web page that accepts R code. You hit a button and it shows you the response right away. It is just like what we would do in our IDE of choices, whether it's our Studio or VS Code or whatever have you. It is now completely in the browser. And the other great benefit of this is that this is, you might say, as close to universal as we're going to get. Does not matter if I'm running this on my favorite Linux installation, Mike's over on Windows, or our colleagues on Mac. It's all going to be the same. It's all web browser compliant. This means accessibility to this technology is already a huge win here. Now, this is early days, right? So I'm going to say just up front, there's a bit of a learning curve to get up and running because it does require some knowledge of JavaScript to bring in the dependencies and to get the environment set up in your web page that you're hosting to do it all. But George has provided a very comprehensive getting started guide that's linked in this blog post. But the other things I want to touch on here are just, again, what is really possible. Already mentioned an online R console so you could quickly do a data analysis and have it ready to go. But think of the idea of education here. How many times have either we done workshops for colleagues, or if you're in academia, you've got a class of introductory statistics or introductory data science, and you want to leverage R because obviously R is very good for data science. But then you get to that part of the syllabus where you say to your students, okay, got to install R version what and what. You got to get an IDE set up. You got to get everything set up. Just imagine instead of that setup, you have a course web page that has webR baked right in. Good grief, that's going to make things a lot easier, I think, from an education standpoint. That's just the start of it. I think this also has huge implications to what we do with web technology as a whole and how we share this with other people. This has been a hot topic in my circle in life sciences where we think about something I'll be talking about at the Shiny conference later this week about sharing an app with health regulators in a traditional Shiny sense. But boy, what if the future holds for maybe sharing a complete WebAssembly like environment that's not a container, that could be a lot more lightweight, but yet has all the analytical dependencies baked right in to replicate our analyses. Again, I'm thinking really big picture here, but this is a massive improvement. The other con to be aware of just for now is that there is a set of packages in the R ecosystem that George has available via a public repository of sort. But any package that has a lot of dependencies or system dependencies, maybe a compiler or things like that, are going to need a little extra help to get into this public repo. So you won't find the whole CRAN repository replicated here. But this is a start, and my hope is that hopefully this there will be feature parity in terms of package availability in the coming days, maybe not days, maybe months. Who knows how long it'll take? But it's all the building blocks are here. So I'm really excited to see where the community takes this, and I have not given it a spin yet. But just as soon as this was announced, another person I admire very much in the community, Bob Rudis, has been hard at work compiling a assorted suite of example apps, how he got started setting this up with his custom server, and yes, even a really attractive looking dashboard that you would have thought was a Shiny dashboard or something like that, but it's all using webR under the hood. So these are going to be fun times, Mike. I'm curious what you think about what's happening here.
Yes, they are going to be fun times, and this is a huge announcement. I'm glad we're starting off with it. I think it's actually going to probably take up the majority of the highlights today, which well deservedly so. And like you said, when we talk about reproducibility, I think that's one of the big things here. The interesting thing about WebAssembly is that the WebAssembly VM is consistent across multiple different types of environment, architecture, and device, as you said. And I think you were just speaking in hypotheticals when you said Mike is on Windows, right? We don't actually admit that to the world, but in theory, right, you should only have to worry about having the correct R package versions and not have to worry about potential differences in hardware like we sometimes have to do when we get a note from CRAN saying our package build failed on something called Solera that no one has used in a long time. Does that sound familiar?
Oh, don't even. Oh, that's Solaris. For those that aren't aware, I actually had to use Solaris in grad school, and it was not pleasant. So, thanks for that callback.
Well, that kind of hammers home my point if you were using it in grad school. Just kidding. Um, but I guess this opens up a ton of possibilities and a ton of questions, right? Is all of our work going to move to the browser eventually? Are we not going to be working on desktop applications anymore? What happens on the day that the internet goes down? If that's the case, was SVB a bank bailout or a tech company bailout? I don't know. I have so many questions right now that I'm trying to figure out. But one of the possibilities, as opposed to a question that this may enable, that George pointed out, which I had not thought of yet, was running examples from our package documentation right in the browser. Because, as of now, if you see a package that you like, maybe you're on the package down site or the GitHub repository, and you want to test out some of the examples yourself, you would have to clone that package or install that package on your own machine. And it might be nice to have something someplace like webR, a dedicated environment that is separate from your own machine, where you could run just some of these, toy examples to really get your hands dirty before you decide to take the full step of installing that package on your own machine. And it makes me think of sites I've been on, like I think Stack Overflow has the potential or the possibility to do this that I've seen before, or the W3 school site. In some languages, they have buttons in the browser that allow you to run and edit that code right in the browser. So I'm assuming that is WebAssembly-ish, and is similar to what we're looking at here. And like you said, I'm just super excited to see all the different POCs that come out of here. I think Bob Rudis is a fellow New Englander who hopefully is not hopefully, but maybe hopefully for us is going to get bogged down by the storm for a few days, so he can continue to develop some really cool POCs with webR that we can all take a look at and leverage and extend in our own way.
Yeah, and speaking of your excellent use case of seeing a package and being able to try it out without committing to installing it, yeah, my hack around that issue of not, necessarily opting into that to my main system installation, but then still trying out has been Docker containers. But again, that's a bit of a hefty footprint if I just want to try a new package that I see in this week's R Weekly issue. What if this was run in the web browser? And of course, this is me talking really big here. I don't know if they're listening. Can you imagine if what we talked about last week with using our universe to discover packages, that if that had a way of running one right on the spot to try it out? I'm just saying, I don't work for our open side, but might want to keep an eye on this. Who knows?
Yeah, if there was just some sort of little tab panel or pop out on each package's page on the R Universe website that would allow you to run a little bit of code within that package, that would be incredible.
Oh, I would be all over that. And what's nice is we're going to be able to see all this happen, and I'm again really excited to try this out, but I think there are implications to this that probably we haven't even dreamed of yet. And certainly from an engineering standpoint, there are tons of possibilities for how this could be used to orchestrate complicated systems in a more modular approach that don't necessarily involve the traditional backends. I think this is massive here.
Absolutely.
And I'm going to tease this a little bit earlier, but you think of the ideas of both the education aspect and reproducibility aspect. What is one fundamental technology that we've been talking about for quite a bit here on our weekly highlights that has totally revolutionized or taken reproducible analysis to the next level? That's, what do you think? Quarto. Quarto, of course. And guess what? Our next highlight is a great tie in to how webR and Quarto could potentially live in harmony, so to speak, where we have James Balamuda, who goes by the fun handle of Cultless Professor. He's an assistant professor at UIUC here in the US. He has created a proof of concept Quarto doc that embeds executable code chunks with webR to simply run that in your browser. So again, these are code chunks that when you look at it, you might think, okay, well, he's just put in the code and I'm just going to hit a button and I can run it. You can modify that code in the web browser and run it differently if you wish. So think of how cool that is. So first he starts off with let's become like a hello world in R for tutorials is fitting a linear model with the empty cars set. But again, once the page loads, you get that run code button. I'm literally running this right now. I get a summary of a model fit right in my page. And if I wanted to, I could tweak that fit. I could run it again and get the updated result. What was a neat aha moment for me is that these chunks are not isolated. Much like in your typical R session, if you do an object or you're reading a data frame and you can use that later on in your remaining functions, you can also, in these webR chunks, reuse existing objects like the model fit. So I could get the ANOVA table of it or the coefficients of it. You can mix almost any type of R code for this. Conditional logic, he has great examples there. Graphics from both base and ggplot2. Now, ggplot2 does require an installation up front, but once you get it installed using one of the webR convenience functions, then you can have a ggplot2 visualization. So again, this is just scratching the surface of what is possible. Look at the big picture what Quarto brings you, right? Is that Quarto is giving you first class support for multiple computation engines. So in this same doc, imagine you could have webR to help with the online, or you say online version of R embedded inside. You could also do the same for Python and have it in the same doc. Isn't that mind blowing? Like this is massive. So as we saw webR get announced, one of the biggest, I would say, cheers I heard on social media was from educators because again, I think with Quarto combined in an education mindset of a workshop or a class, this is going to immensely help the teachers, but also the students to really learn these concepts without getting bogged down into a lot of the, some say, minutia of system installations and the like. But this is a huge set of potential here for what Quarto can do with WebR. So really great to see this example. So we'll have a link in the supplements to the repo behind this Quarto doc so you can get a feel for some of the custom JavaScript that had to be built to make it happen, but it's really not that difficult once you get through some of these early tutorials. Obviously, this space is going to get even easier to play with this, but I think for now, this is a great teaser of what's to come here. So I'm excited to say the least.
Yes, absolutely. And this was super fun to play around with. And you know, like I was saying before, I foresee and very much hope that a million more WebR examples like this one come out over the coming weeks and months so that we can all work together to find the best and unique ways to use it. Give me all the POCs. I, like you, really enjoyed clicking on the run code buttons above each code chunk, even modified some of the code in the chunks and then reran them and saw the output change. It's kind of like a little surprise the first time that you do it and you're like, "Oh my goodness, I can actually edit the code in this chunk." And then when I click run, it changes. It's I don't know how to describe the experience the first time coming from a huge R nerd, but it's certainly fun. And it, like you said, it has so much promise for teaching R to others without worrying about downloading and installing R in our studio. And the one area I think that's a little bit of a pain point, in my opinion, still is how long it does take to install other packages. You
Correct.
know, I know that there is a lot that you can do with base R installation, and trust me, I'm all about reducing dependencies wherever possible. You know, but what does make R great is the open source community of the packages around it. And that last code chunk of this Quarto example with webR does involve ggplot2, as you said, and you first have to run, you know, webr install ggplot2. And for me, at least, it takes about 2 minutes for that chunk to run the first time, which is a little bit of time. I guess maybe we're a little spoiled these days with how fast you know, we've gotten some of the tooling that we use to run. So maybe it's not that big of a deal to others. But the nice thing is that once you run that the first time, you know, if I make a change to the code and then rerun the chunk, it's very, very quick to respond. Took me about 3 seconds to change the to flip the chords on that plot. So that was pretty cool to see. Hopefully, it's just sort of that install is more of a one and done type of situation. And one last note on Quarto. Maybe this will be in next week's highlights, but maybe I'm getting to it a little too early. It looks like version 1.3.0 of Quarto was just released and has some really cool updates, including one that I saw was big improvements to code annotation. That was interesting. So take a look at the latest release and feel free to play around with it.
Yeah, it's that's a terrific release coming up. The active development is still, yeah, very active. Very interested to see what other features are in store for us. But it, having these two technologies play together, I think, yeah, the POC stage, we're going to get our hands on a lot of this stuff. But these issues of like compilation times and waiting for execution, I think in the long run are going to be solved. There are a lot of brilliant minds that are attacking this problem, and it's only a matter of time before it ends up being a seamless process to have this, again, what George has set up, this kind of public repository of webR compiled packages. That list is just going to get bigger and bigger, which means then we don't have to be as attentive about only using base R from the start. I think it's going to happen, just a matter of time. But again, the engineering behind this is absolutely massive. I've done a little poking around the webR repo, and I could never pretend that I would be able to come up with any of that. So I'm very thankful that we have some brilliant minds behind the scenes on this. And yes, as I mentioned, the thought of engineering that makes my head spin a lot. And there's no denying that technologies like Shiny, WebR, and many things in the art community that we use daily have a lot of great engineering behind it. But then you think about, in your case, if you're a researcher, you're a data scientist, you're using R to do kind of your bread and butter, so to speak, of getting your analysis done and sharing it with others. You may have never had training in a computer science course to learn some of these, what I might say, tools of the trade or tricks of the trade of making your engineering life easier. Well, if you find yourself in that situation, then our last highlight is definitely for you to ponder on. And that's where Bruno Rodriguez, who we just mentioned last week in my little teaser about his online reproducible research, an R book, is back at it with a great blog post detailing software engineering techniques that the non programmers who are still writing a lot of code for their data analyses can benefit from. It boils down to two of them in particular, both of which we mentioned in different places in previous episodes, but we're going to summarize them very nicely here. First, the DRY or dry principle. Don't repeat yourself. So, this was a lesson I learned the hard way from many, many years ago in my early days of coding with R, or even in the very early days of SAS, but we're not going to talk about that much. But it's the idea of, if I'm writing this set of code that does maybe a transformation or a summarization, and maybe I tweak it a little bit for a variable here and there, but I end up copying, pasting the majority of that code, just changing one thing. If I do that more than 3 times, and Hadley will probably come after me and say, you need to write a function. Bruno says the same thing. Says it's very easy once you get the hang of this, and so many benefits of writing a function to simplify your process. And also finding functions to make your life easier, such as uh, kind of hidden gem in the R base R paradigm, the reduce function. So if you, in the example he has here, where you're adding literally the numbers 1 to 100 together, instead of literally writing 99 or those plus signs in between them all, you can use the reduce function to apply the function behind addition, the plus operator, on that sequence. And hence now you've written maybe 10 or so characters instead of who knows how long that string would be. So just knowing these little gems inside, along with making sure you don't repeat yourself in your custom code, is a huge help to you. And that gets to kind of the broader topic of literate programming, where, again, we just mentioned Quarto, right? The idea behind Quarto is that I can run a set of code to get an output, get a visualization, get a table, but that table or that visualization is not something I have to copy paste from like my R editor or whatever over to that final finished product. Manual copying pasting will bite you. It's just a matter of when, not if. Trust me, I know from my early days of PowerPoint slides, which I still kind of have to do, but I try to do it in the reproducible way now. So there's great examples of why a Quarto can be a huge benefit in that space. And then the other one, WIT, write it down. This would have been very helpful for yours truly when we were recording the last episode of our weekly highlights, but we're not going to get into just why exactly. But writing it down is never a bad thing. Always document what is the purpose behind maybe your custom function, or maybe the purpose behind using a certain package. Like, it does not ever hurt you to document more for yourself, such as in another example that he mentions in the post. If you have a raw data set where you know there's been some kind of data collection error, a misclassification of maybe or like a categorical variable, it's always tempting to get into the weeds of that CSV file, just change those 2 or 3 rows, save it out, and then carry on with your day. Well, guess what? Future you and your future researchers won't know you did that. That's why if you can do that through code and write it down why you did it, then you can run that and treat your raw data as what it should be, your raw data. I've learned in my industry, you never touch your raw data manually. You always find a way to automate the processing of it, automate any derivation so that you can reproduce that, whether it's tomorrow, next year, or 5 years from now. So these are things that, again, when I say them out loud, they seem really logical. But knowing how it was for me back then, I just didn't have the knowledge to articulate these ideas in my head very clearly. So I think if you're in this space and you're just either getting started on your journey or you've been doing this for a while, but you kind of been doing it the quote unquote manual way, these two principles are going to save you a bunch of time, and also your collaborators, any reviewers of your analysis. There's only good things to happen. Sometimes it sounds intimidating, but we're not expecting you to become the next engineer that's building WebAssembly. This is just for you to make your life easier.
Yes, no, this is always a great reminder, and I appreciate Bruno kind of putting all of these thoughts, writing it down, if for lack of a better word. And one thing about Bruno as well, on top of this post, is that he actually recently, I believe, released a free ebook that is called "Building Reproducible Analytical Pipelines with R," which I think touches on a lot of these practices. And I can't agree more with what you said, Eric, and what Bruno says, especially the write it down portion. I recently been working on an R package that I've been really heads down in, and I can't tell you how many times during the course of my actual, Roxygen documentation or unit test, I went back and edited the function, realized an issue with the logic that I wrote for the function itself that I would not have realized until I went through that step of documentation, or until I went through that step of unit testing as well. So I know some of this stuff to the uninitiated can seem maybe like overkill or unnecessary, and that you really just want to focus on the code and getting from point A to point B. But if you are doing, some sort of scientific work that matters, that's going to make an impact, that people are going to be making decisions on, I think that you should really, really care. It should really, really matter to you that you are doing everything that you can to get the correct results at the end of the day. And that should involve both of these principles: the dry principle, to ensure that any logic that you're creating is just sort of created in one place, and you can leverage it in different places, and reuse it instead of copying and pasting, as well as writing things down and unit testing and documenting the work that you are doing, to ensure that whatever scientific analysis that you're doing is rigorous. So I think you said it great. I think Bruno said it great. For some of the instruction that I'm doing, we actually do quite a bit of what we call office hours, for folks who are looking to upskill in our package development, our Shiny development, and things like that. And sometimes I have a difficult time articulating why these principles are really important. So I am probably going to pull out this blog post before our next office hours, and give myself some talking points, to help hammer home why these principles are so important, because I think Bruno does a great job articulating that.
Yeah, that's a great insight there. In fact, at the day job, myself and my teammate Will Landau also lead an office hour of sorts for people that come get their help with R and computations and general inquiries. And a lot of times what we try to do is not just say, okay, here's a solution. We try to help lead them a why that's a valid solution and then give them resources to learn more about why we recommend that. I think that, yeah, posts like this are a great way to tell you why this is important. We don't want people to always find out the hard way. We always want to try to get up front and try to tell them, yeah, if you make this a function, your life will be easier. And frankly, even for people to help you out, if you do run into a problem, the function approach, writing this down and not repeating yourself, is going to make it easier for you to produce those reprexes we talk about a lot as well, where instead of having to untangle a spaghetti mess of interactive like code that you copy pasted from your R console back to your source script, and you kind of have weird comments along the way, having a functional approach is going to make your life easier as well. What I will say has happened is that we have another fantastic issue of our weekly here. Sam, as I mentioned, did a tremendous job. So we'll take a couple of minutes here for our additional finds. And for me, of course, on top of the buzz for webR, what's been buzzing for a bit now in the general tech sector has been obviously the use of AI in certain paradigms like ChatGPT. Well, I've always, been optimistic, but also a bit cautious about where this could be most useful. But this additional find I have is a great example of how it can make life better. So we have Sebastian Krantz, who's a professor at Ulm University, has created a simple little shiny app to help basically be a text search amongst economic journals for keywords. And that's all fine, works great. But what he's done in this write up that we're going to link here is that he's now augmenting the OpenAI API to bring in a way for the user, once they get a search result of an article that matches that keyword search, there's a little button that says, okay, now give me similar articles. And that's where he's calling the OpenAI API to grab that information. So you can see it's not replacing something, it's augmenting what we already have. I think that is, to me, where I think this technology can really help without making me feel like it's trying to do too much at once. And related to that, I also want to give a shout out, a little bonus find, somewhat related, but David Smith gave a recent presentation at the New York City Data Hackers Meetup about how you can use GitHub Copilot for R, but it's not just using Copilot on the traditional way with VS Code. He talks about using the OpenAI API to help bring those results in. So it's very timely. We've been seeing some front ends, if you will, to like Chat GPT to also do the same thing with the general OpenAI framework. So I think it's an interesting way to help your development, but also a way to augment an existing application, an existing analysis with some additional relevant, pieces of information. So interesting stuff to read about for sure.
Oh, that's a great find, Eric. One thing that I found that I was really interested in is another Bruno Rodriguez shout out to his blog. It's called "What I've Learned Making an .epub ebook with Quarto." So I know that a lot of folks are big lovers of Bookdown, which I believe leverages our Markdown and maybe looking for ways to create a book using the Quarto framework. And this is one of the first examples that I had seen. So he has a blog post around this, as well as that ebook that I was just talking about called Building Analytical Pipelines or Building Reproducible Analytical Pipelines with R that he's working on right now, which is a fantastic ebook that covers all the basics of getting yourself up and running with R and version control. There's a section on collaborating with GitHub, which I think is a topic that does not get enough attention, as well as building automation with the targets package. Everything's in there. I know a few of the later chapters are still works in progress, but it's looking like it's going to be a phenomenal resource for folks out there in the community. So keep an eye on that, and great work, Bruno.
Yeah, it's great to see the technology being blended nicely. And maybe if I ever get the adventure to write a book someday, these are going to be things I'll be using as templates. So, really cool stuff, Bruno. And also, we love not just hearing what these innovations are in each our weekly issue, we love hearing from you as well. So if you like what you've heard and you want to get in touch with us, we got a few ways to do so. You can head to the episode show notes for a direct link to our contact page if you'd like to send us a quick note on that. Also, if you're using one of those fancy modern podcast apps that are completely free, like Fountain or Podverse, you can send us a little boost right inside the app. We got complete details of how to get started with that in the show notes as well if you're interested. And certainly a big shout out to all of our previous boosters out there, including Chris from Jupiter Broadcasting recently. It was very nice of you to do that. So please keep them coming. And also, if you want to get involved with RE Weekly itself, you see a great resource that you want to have to shared in the next issue, simply head to our rweekly.org home site. There's a direct link to the upcoming draft in GitHub. It's all markdown all the time. If you're writing Quarto docs, you're writing markdown. So this is very easy to get started. Just send your pull request there, and our curator of the week will be glad to merge that in. And we love hearing from you on social media as well. You can find me somewhat sporadically on Twitter with @the_rcast, and more likely on Mastodon with @rpodcast at podcastindex.social. And you'll be seeing and hearing me at the upcoming Shiny Conference, which, if you're listening when this episode is released, is literally happening this week. So get registered if you're not already. But, Mike, where can they find you?
Yeah, same on Twitter at Mike_Ketchbrook and Mastodon at Mike_Thomas at Fostodon.org.
Awesome stuff. And yes, we're both going to be very excited to be a part of the Shiny Conference. And yeah, we got other big things planned later in the year that you'll be hearing about very soon. But until then, we're going to close up shop for episode 115. And we'll be back with episode 116 of our weekly highlights next week.